First point, create a node Tn, the graph for each participating transaction in the schedule. Draw the edges from one transaction to another transaction and satisfy any one of the following conditions. What are those conditions? Condition 1. If transaction 1 execute write operation, that means write of x, followed by transaction 2 execute read operation, read of x. So then we can draw the edge. We can draw the edge between two transactions. Okay. Are you getting my screen? Next, condition 2.
Yes.
When transaction write off x, then I draw the edge. Operation for x. Then I can draw the edge. Here, read operation of x data item, write operation for x data item. Then I can draw the edge from T1 to T2. Okay. And the third condition, write of x followed by T2 executes write of x. Write operation. Then I can draw the edge. So in which situation? Write, read, write. Remember these conditions to draw the precedency graph. We have transaction 1, transaction 2, and transaction 3. Okay, from transaction 1, I am performing reading operation of a data item. Performing of a data item, and T3 transaction I am going to perform read of B data item. Next, here I am performing in T1 transaction, I am performing writing operation of on a data item. Then in T2 transaction, I am performing read operation on C data item, read operation on B data item, read operation or write operation on B data item. And in T3 transaction, on perform write operation on C data item. Now tell me how to draw precedence graph here. This all of you see. I'm going to draw the precedence graph here. Try to understand. So what are the edges we have? What are the transactions we have? T1 transaction. Next T2 transaction. T3 transaction. Okay. In T1 transaction, we have read operation. T2 transaction, we have read operation. Read to read not possible. So first, the transaction start from read, right? So read operation. After that, the means from T2 to T1 we have read operation of a data item, write operation of a data item. That means it starts from T2. So I can draw edge from T2 to T1. T2 to T1. What operation? A read operation of a data item to write operation of a data item from T2. See, in this way I should write. After that, see next next edge, next conflict edge. From T3 I have read B. So where is the write B? In T2 operation I have write B, write of B. So now I can draw T3 to T2. T2. So now I can draw T3 to T2. That means read of data item B to write of data item B. Okay. Next C. So C, from data item C, I do the data item C. So where is the write of C? Write of C. Okay, we have write of C, right? So I can draw edge from here to here. That means from T2 to T3 I can draw the edge. T2 to T2 to T3. T2 to T3. Read and write operation. So that means how I have written this. Read operational C data item, write operational C data item. So in this way I can write this graph. Here a cycle is not there. Yes, I have the cycle here. From it starts from T3 and ends at T3. This is cycle. So here cycle is serializable. If cycle form means it is what? Non-serializable. Are you getting? Here we have transaction 1, transaction 2, 3 transactions we are doing simultaneously. At the time we are performing this read and write operation in T1. and here I am performing read operation of A item, read operation of C item, read operation B item, write operation of B, and in T3 transaction performing read operation of B and write operation of C. Now how can I write the precedence graph? So here read operation
Sir, you are under mute.
Now,
Okay, sir.
how you understand the concurrency control? See, some persons are trying to book the tickets. Okay, so they are accessing simultaneously. So in the same time, same minutes and seconds, also there is no difference. So they are trying to access. Here he is performing right operation. He is trying that same booking same seat. Okay, he's trying to book the same thing. So now it is going to get data inconsistency problem. Now to avoid the problem, should locking mechanism. We should perform locking mechanism. Lock. See, first I'm locking a data item. Here, and I am performing the write operation on a data item. E7, mute yourself. E7, E7, mute yourself. E7, E7, mute yourself. I'm performing locking operation here on a data item. Then I can perform number of operations on this transaction, write operation, something select operation and update operation and all. Then after unlocking only, the other transaction can access the data item. So while if you are providing locking on a data item, here the T2 okay. So after completion of unlock, then we can perform read operation here. Okay. So that in that situation, it is going to be in lock system. It is in lock system. Then here also we perform all operation, then unlock, then T2 going to get the operation, going to perform some operations. So in that way we need to perform locking mechanism. We need to follow binary lock, shared or exclusive lock. Okay. So what is concurrency control? Have you understand the concurrency control? Concurrency means what? Simultaneously two persons trying to access the same data. Multiple transactions we are doing at a time. So in case of concurrent instruction executions, to preserve atomicity, isolation and serializability, we use lock-based protocol. We use lock based protocol. In which case, in case of concurrent instruction executions, to preserve atomicity, isolation and serializability, we use lock based protocol. Like we have two types of locks. First one is what? Binary locks. Binary locks. Binary means what? A lock on a data item can be in two states. A lock on a data item can be in two states. Either it is locked state and unlocked state. That is called binary lock. Either it is locked state or unlocked state. Coming to shared or exclusive locks. Shared or exclusive lock. Shared or exclusive lock. So this type of locking mechanism, in this type of locking mechanism. So shared means what? While sharing a data item in the transaction, so we can perform only read operation. Coming to exclusive locks, we can perform read or update operation. That means read and write operations we can perform. That is the main difference, shared and exclusive. See here, the shared and exclusive, this type of locking mechanism differentiates the locks based on their uses. If a lock is acquired on the data item to perform a write operation, it is an exclusive lock. What is an exclusive lock? If a lock is acquired on the data item to perform a write operation, it is an exclusive lock. Allowing more than one transaction to write on the same data item would lead the database into an inconsistent state. Read logs are shared because no data value is being changed. No data value is being changed. So here we have lock compatibility matrix. We have lock compatibility matrix. Lock compatibility matrix controls whether multiple transactions can acquire locks on the same resource at the same time. What lock compatibility matrix do? Lock compatibility matrix controls whether multiple transactions can acquire locks on the same resource at the same time. If a resource is already locked by another transaction, one resource is already locked by another transaction, then new lock request can be granted only if the mode of the requested lock is compatible with the mode of the existing lock. And second point, any number of transactions can hold shared locks on an item, but if any transaction holds an exclusive lock on item, no other transaction may hold any lock on the item. Here compatible locks held by other transactions have been released. Then the lock is granted. So we can grant the lock. Diagram shared and exclusive. Shared means this is allowing. What is applicable, what is not applicable. Shared is true. Shared exclusive false. Exclusive shared false, and exclusive false. That's what about this diagram, and we will discuss lock granularity here. Okay, in that database level, table level, page level, row level, attribute level. We'll discuss. Lock granularity means a database is basically represented as a collection of named data items. We have collection of named data items. The size of the data item chosen as the unit of protection by a concurrency control program is called granularity. What is granularity? A database is basically represented as a collection of named data items. Database basically represented as collection of named data items. We have named data item. Okay. The size of the data item chosen as the unit of protection by the concurrency control program, then it is called granularity. So here locking and locking takes place by using database level locking, table level locking, page level locking, row level locking, or tuple level locking, or attribute level locking. We have different types of lockings, different levels of lockings. Okay, we can provide locks on database level, table level, page level, row level, attributes level. Sir, what is page level? See here, we have one database having number of tables. Each table having number of records or number of tuples. Okay. So paging is, see here, you know already paging technique. So we have two rows. We are going to display one page. So these two rows are called page. For each page, we have only two records. So that is called a page. So in this locking system, locking granularity, we are performing on database level, okay, table level, page level, row level, and attribute level. Okay, that means fields. Each table have fields, right? Serial number, student number, student name, field level. So we can provide locks on database level, table level. See here, database level, table level, page level, row level, and attribute level. Are you getting? Here, database level locking. Database level locking. A database level locking, the entire database is locked. Database level locking means what? Entire database going to be locked. Thus, it prevents the use of any tables in the database by transaction 2 while transaction T1 is being executed. The database level of the locking is suitable for batch processes, being very slow. It is unsuitable for online multi-user database management system softwares. Okay. So database locking can perform on entire database. Entire database going to be get locked. Then if you are performing T1 operation, the T2 operation while you are doing T1 operation, so the database level of locking is suitable for batch process. So it is going to be very slow. Okay, it is unsuitable for online multi-user database management system applications. Okay, that's about database level locking. Coming to table level locking. Table level locking. At the table level locking, the entire table is going to be locked. The entire table is locked. Thus, it prevents the access to any row, means any tuple, by transaction T2 while transaction T1 is using the table. If a transaction requires access to several tables, each table may be locked. However, two transactions can access the same database as long as they access different tables. Table level locking is less restrictive than the database level. Table level locks are not suitable for multi-user database management systems. Okay. So what is table level locking? What is the problem? So a table level locking means the entire table is going to be locked. The entire table is locked. Thus it prevents the access to any row by transaction T2 while transaction T1 is using the table. If a transaction requires access to several tables, each table may be locked. However, two transactions can access the same database as long as they access different tables. The table level locking is less restrictive than the database level. So the table level locks are not suitable for multi-user database management system. That's about table level locking. Coming to page level locking. See, at page level locking, the entire disk space or disk block is locked. A page has a fixed size such as 4K, 8K, 16K, 32K and so on. A table can span several pages. Okay, and the page can contain several rows of one or more tables. Page level of locking is most suitable for multi-user database management system softwares. Okay, I said right, pages means so two or more rows from this table and two or more rows from another table. That is one page. So what is page level locking? A page level locking, that means the entire disk space or it is going to be locked. The disk block going to be locked. A page has fixed size such as 4K page or 8K size of page, 16K size of page, 32K size of page we have, and so on. A table can span several pages. Okay, and the page can contain several rows. One page having several rows or one or more tables from one or more tables. That is called page. A page level of locking is most suitable for multi-user database management system softwares. So that's about the page level locking. Coming to row level locking. So you know row, right? So at row level locking, particular row is going to be locked. Particular row is locked. Means one tuple is locked. A lock exists for each row in each table of the database. The database management system allows concurrent transactions to access the different rows of the same table, even if the rows are located on the same page. Even if the rows are located on the same page. The row level lock is much less restrictive than database level and table level or page level locks. The row level locking improves the availability of the data. However, the management of the row level locking requires high overhead cost. Cost is high. Are you getting row level? Row level means we are providing lock to row level. The row is available in the table. The table is available in the database. That means we are providing row level locking. That means we are providing row level tuple level locking. That means what? A lock exists for each row in each table of the database. The database management system allows concurrent transactions to access the different rows of the same table, even if the rows are located on the same page. The row level lock is much less restrictive than database level, table level, or page level locks. Less restrictive because it is locking only the row. The row level locking improves the availability of the data. That means the data available in the database. However, the management of row level locking requires high overhead cost. If you are performing row by row locking, so the managing of row level locking requires high overhead cost. Next, after row level locking, we have attribute level locking. Attribute level locking. What is attribute level locking? We are performing locking on attribute level. That attribute is available in the database. From database contains the table, table contains the attribute. Right? At attribute level locking, particular attribute or particular field, some for example, student ID is locked. Attribute level locking allows the concurrent transaction to access the same row as long as they require the use of different attributes within the row. The attribute level lock yields the most flexible multi-user data access. It requires high level of computer overhead. That's about attribute level locking. Here we are providing lock for what? Attribute, particular attribute, like student ID for a student name, or course ID, course name, whatever. We are providing locking for particular attribute. That means what? Attribute level locking allows the concurrent transactions to access the same row as long as they require the use of different attributes within the row. The attribute level lock yields the most flexible multi-user data access. It required high level of computer overhead. Those are the levels of lock granularity, database level, table level, page level, row level, and attribute level. We can perform locks on database level, table level, page level, row level, attribute level. If you perform database level, no one can access. Table level, databases can access, but they cannot access the table. If I perform page level, they can access the table level, but cannot access. Same thing for row and attribute also. This all of you. Okay, in the tomorrow class we will see locking protocols also. Okay, so what are the locking protocols we have? Simple lock based protocol, conservative, two-phase locking, strict two-phase locking, regular two-phase locking. So we will see in the next class. Okay.